Good day everyone, I am Fusion B. Palmero from 1 BSEA, and today I am going to show you how to solve the derivative of trigonometric function. But before we go to our example, we must be familiar with the following formulas. The derivative of sin x equals cosine x, derivative of cosine x equals negative sin x, derivative of tan x equals secant squared x, the derivative of cosecant x equals negative cotangent x cos secant x, the derivative of secant x equals secant x tan x, and the derivative of cotangent x is equal to cosine squared x. So our example is f of x is equal to x squared sine x. So this is our example. As you can see that our example is the product of two functions. Let's say that g of x is equal to x squared, then h of x is equal to sin x. So we can solve this derivative of trigonometric function by the product rule. Our product rule is, but first, this means that f of x is equal to g of x times h of x. Therefore, f prime of x is equal to g of x times the derivative of h prime of x plus h of x times the derivative of g prime of x. Then we will put it into our example, which is the f of x is equal to x squared times sin x. Then, therefore, f prime of x is equal to g of x, which is x squared, times h prime of x, which is the sin x. So, as what I have said earlier, that the derivative of sin x is equal to cosine x plus h of x, which is sine x, times the derivative of g prime of x, which is x squared, that will become 2x by the power rule, Then we will solve this. Therefore, our answer is f prime of x is equal to x squared cosine x plus, we can write this into 2x sine x. So this is our final answer. F prime of x is equal to x squared cosine x plus 2x sine. I have another example. Our second example is y is equal to 2 cosecant x minus 1 all over cosecant x plus 2. As you can see that our second example is the quotient of two functions, which, let's say, g of x is equal to 2 cosecant x minus 1, and h of x is cosecant x plus 2. So our y is equal to g of x over h of x. Therefore, our y prime is equal to h of x multiplied the derivative of g prime of x minus g of x times h prime of x all over h of x squared. So let's substitute this value in this equation. H of x, which is our denominator, cosine x plus 2 multiplied to g prime of x, which is our g of x is 2 cosine x minus 1. So g prime of x is 2 times cosine x. The derivative of cosine x is negative cotangent x secant x. Negative cotangent x cosecant x. Then negative 1 is equal to 0. Minus g of x, which is our numerator, 2 cosecant x minus 1. 2 cosecant x minus 1. Multiply to h prime of x, the derivative of cosecant x is negative cotangent x cosecant x plus 2, which is 0. So this is multiply to negative cotangent x cosecant x all over h of x, our denominator, cosecant x plus 2 squared. We will multiply first this sign so that we can proceed in another solving. So this is cosecant x plus 2 times negative 2 cotangent x cosecant x multiply to negative times 2 cosecant x minus 1 is negative 2 cosecant x plus 1, then copy negative cotangent x cosecant x all over cosecant x plus 2 squared. So we will multiply cosecant x plus 2 to negative cotangent x cosecant x. So the answer is negative 2 cosecant squared x cotangent x times negative 4 cotangent x cosecant x. Then negative 2 cosecant x plus 1 multiplied to negative cotangent x cosecant x, which is plus 2 cosecant squared x cotangent x positive 1 times negative cotangent x cosine x is negative cotangent x cosecant x all over cosecant x plus 2 squared. So we can cancel this positive 2 cosine x cotangent x and the negative cosecant squared cotangent x. Then our final answer is y prime is equal to negative 4 cotangent x cosecant x plus negative cotangent x cosecant x is negative 5 cotangent x cosecant x all over cosecant x plus 2 squared. So this is our final answer. Next is the derivative of logarithmic function. But before we go to our example on how to solve the derivative of logarithmic functions, we must bear in mind that the derivative of ln u is equal to du over u, and the derivative of log u with the base a is equal to du over u ln a. And now, for our example, ln x raised to 4 plus 2x. So the derivative of ln u is equal to du over u, where our u is equal to x raised to 4 plus 2x, and our du is 4x cubed plus 2. So du over u, let's just substitute this to the formula. 4x cubed plus 2, which is our du, over the denominator u, x raised to 4 plus 2x. So the derivative of ln x raised to 4 plus 2 is equal to 4x cubed plus 2 over x4 plus 2x. I have another example. Our next example is log of x over x plus 1 with the base 7. So the formula that we are going to use is this one. So log u with the base of a is equal to du over u ln a. So our du and u is, our u is x over x plus 1. Then our du is equal to v du minus u dv over v squared. Our v is equal to x plus 1 times the derivative of u, which is 1, minus u, our u is x, then the derivative of v is equal to 1 all over v squared. Our v is equal to x plus 1 squared. So the answer here, x plus 1 times 1 is equal to x plus 1 minus 1x. So we will write it as x plus 1 minus 1x all over x plus 1 squared. So we can cancel out this one, the x plus 1, to the denominator. So our final answer is 1 over x plus 1 squared. So this is our du. Then we will just substitute the values here to the formula. By the way, our a is 7 because it is base 7. So du is 1 over x plus 1 squared all over u is x over x plus 1 times ln 7. So we'll multiply x over x plus 1 to ln 7. So we'll copy first 1 over x plus 1 squared all over x ln 7 over x plus 1. Then cross multiply to get the final answer. We will have x plus 1 over x plus 1 squared times x ln 7. So 1 times x plus 1 is x plus 1. Then x plus 1 squared times x ln 7 is equal to x plus 1 squared times x ln 7. Then our final answer is 1 because we can cancel this out all over x plus 1 times x ln 7. So this is our final answer.
Next is the derivative of exponential function. But before we go to our example, these are our formulas. The derivative of e raised to u is equal to e raised to u multiplied to the derivative of u, and the derivative of a raised to u is equal to a raised to u ln a multiplied to the derivative of u. So our first example is find the derivative of e raised to 5x. So our formula to be used is e raised to u is equal to e raised to u multiplied to the derivative of u. So our e, we will write this, e raised to u 5x multiplied to the derivative of u. Our u is 5x and its derivative is 5. So our final answer is 5e raised to 5x. Another example is the derivative of 9 raised to x cubed. Our formula to be used is a raised to u is equal to a raised to u ln a multiplied to the derivative of u. So our a is 9, our u is x cubed, ln 9 multiplied to the derivative of u. The derivative of u is 3x squared. So this is our final answer. Last is the maxima and the minima. The problem is, find the area of the largest rectangle that may be inscribed in a circle of a diameter of 8 cm. So as you can see that I already drawn the illustration for that problem, which is the area of the rectangle that may be inscribed in the circle with a diameter of 8 cm. So as you can see that the diameter of the circle is also the hypotenuse of this base and this height. So to find the area of the rectangle, area is equal to base times height. So 8 squared is equal to b squared plus h squared. Then we'll equate this to h. So it will become h squared is equal to 64 minus b squared. The square root of h squared is h, so it is equal to square root of 64 minus b squared. So this is the time that we will differentiate. The derivative of the area with respect to the base is equal to b multiplied to the derivative of negative b squared is 2b, negative 2b, over 2 square root of 64 minus b squared. Then plus square root of 64 minus b squared times 1. So we can cancel out this 2 and this negative 2. Then it will become the derivative of a with respect to its base is equal to negative b squared, because b multiplied to negative b is negative b squared, plus square root of 64 minus b squared times square root of 64 minus b squared over square root of 64 minus b squared. Then we will equate it to 0. Then you can cancel this out, and it will become 0 is equal to negative b squared plus 64 minus b squared. So negative b squared minus b squared is equal to negative 2b squared plus 64. Then transpose, it will become 2b squared equals 64. Then divide both sides by 2. Then b squared is equal to 32. So square root of b squared is equal to, b is equal to square root of 32, which is 4 square root of 2. So our base is 4 square root of 2. Then we will equate it here to this formula, which is h is equal to square root of 64 minus 4 square root of 2 squared. So 4 times 4 is 16, then times 2 is 32. So square root of 64 minus 32, our h is also equal to 4 square root of 2. Then area is equal to base times height. Our base is 4 square root of 2 multiplied to the height, 4 square root of 2. Then our area is 32 square centimeter. So this is our final answer. So the largest area of a rectangle that may be inscribed in a circle with a diameter of 8 cm is 32 square centimeter.